Hi everyone, welcome to events number, George, help me out, where are we now?
I'm going to go 6.
I am going to say, I've actually got it in front of me. It is 1, 2, 3, 4, 5. This is event 6. Event 6, we're halfway there, living on a prayer. And this is our Building with IPFS workshop with the good sir Alan Shaw here to give us a little deep dive into all things IPFS. This is actually our second IPFS event. We had one a couple of weeks ago, nice intro to IPFS, which we greatly enjoyed. And so this will go into a little bit more depth take any questions you may have. Feel free to put any of them into the chat. And we will happily go through any one of them. But Alan, good to have you with you. Good, I can't speak anymore. Good to have you with us, and excited for this one. So over to you.
All right, thank you. Okay, here we go. Okay, there's going to be a whole load of live coding, so wish me luck. All right, cool. So this is, here we are. It's the Building with IPFS workshop. This is a workshop that was originally given and has been adapted from an IPFS camp course, which happened in 2019. And it's called Building with IPFS. So welcome, welcome. Today, we're going to be using IPFS as a building block to in your application. And our goal is to build a basic understanding of how you can use IPFS in your application. So we'll be focused mostly on JavaScript here, since this is probably the easiest way to get started and applicable to most developers. But there's nothing stopping you from building with IPFS in whatever language you prefer. Your choice, honestly. You'll find out later why that is. Yeah, let's get on with it. So here is our agenda. The good news is the introduction was short and is complete. So here we go. So first up, we're going to be talking about provisioning. And so answering the question of where we're going to run, where to run IPFS. Do we run it in the same place that your app is, or somewhere else entirely? Secondly, what to run? Do you want to run a full IPFS node or just the API client? If you're going to run a full node, then which implementation should you run? And do you even want to run an IPFS node at all? Like, would it be easier to use like a hosted service instead? Next up, we'll talk about APIs. How will you interact with your IPFS node? Like, will you be using a programmatic interface? Will you use the HTTP API directly? Is there some sort of client library in your language that you could use? So that's what we'll talk about next. And finally, we'll talk about data. So the type of data that IPFS can store, how to add data to IPFS, how to get it back, how to get data that you didn't even add yourself from the IPFS network. So that's what we'll be doing. So, all right, straight into provisioning then. Let's talk about making sure IPFS is there, or where you need it, essentially. So let's see where IPFS runs today. There's 2 high-level patterns that we're going to consider here. The most common pattern is applications that are interacting with a remote IPFS node over a HTTP API. And so this is especially common from apps that are running in the browser, because in the browser, you can't make outgoing TCP connections to random peers, and you certainly can't receive them. There's no way in the browser to just listen on a socket, listen on an IP address or a port. You can't just receive connections from arbitrary people from the browser. It's just not possible. So in the browser, you kind of have to use WebSockets. WebSockets in the browser, you can make kind of outgoing connections to secure endpoints, so WSS. So the remote node that you're talking to has to be A, have WebSockets enabled, and B, have an SSL certificate for you to be able to talk to them. And secondly, you're restricted to WebRTC, which kind of works, but we found typically it's not so good for many connections. It's good for like a couple of connections to certain peers, but in IPFS, when we're trying to discover content on the DHT, we'll typically end up connecting to many peers, and it doesn't scale so well. We've found that it doesn't scale so well with the WebRTC implementation that we see in the browsers. So it's tricky. Things are tricky in browsers, but using the HTTP API, which is possible from browsers, like allows a IPFS node or a cluster of IPFS nodes to be shared among many users. So, it's all good. And so the HTTP API is the most common API in use, but I know that JS IPFS now has a gRPC API, and it's also worth noting that in this diagram, you can see here we've got a few applications here, 3 applications that are talking to one IPFS node, but that IPFS node could be running on your laptop. So then there would potentially be multiple applications sharing the same node with only one user, but this node could also be running in the cloud, and then there'd be many users and applications that are sharing the same node. So just take into account that it can be anywhere essentially. So the other usage pattern that we see is a embedded IPFS node. It's slightly less prevalent than using IPFS as a service. But in this case, IPFS node is actually running inside as part of your app. So your app could be written in Go and embed a Go IPFS node, or it could be written in JS and embed a JS IPFS node in it. It could even be Rust. There's a Rust implementation. It's currently, I believe, in alpha, so your mileage may vary, but if you enjoy Rust, then you should go check that out. So in this workshop, we're going to focus on talking to a remote node, so essentially running IPFS as a service, since that's kind of the quickest and easiest way for you to get started. Okay, so IPFS as a service. So IPFS as a service, just like you'd run a database like a Postgres or whatever, or like a load balancer or any other service. This is running IPFS as something that you talk to externally from an application. And so you've got some choices here. If you want to run an IPFS node and you're going to self-host it, then you're probably going to want to use Go IPFS. It's the reference implementation. It offers the best performance, I believe, and it's definitely the most featureful. So these other implementations haven't quite got as many features or feature parity with Go IPFS. So if you're looking to use every part of Go IPFS or a particular part, then Go IPFS is probably your best bet of the implementation that actually supports it. Your alternatives, like I said, are JS IPFS or Rust IPFS. JS IPFS is currently missing a robust DHT implementation, so it's not super suitable as a server node in the browser. Yeah, absolutely. But for a lot of kind of workflows as a server node, you kind of want the DHT to be there so that you can find content that you don't already have from the peer-to-peer network. Rust will probably give you that raw performance stuff, but it's in alpha, so your mileage may vary. Try it out though, see what you think. And yeah, so IPFS cluster, if you're going to be storing data that never needs to be lost, then IPFS cluster is going to give you that added redundancy. So basically, you have a set of IPFS nodes, and pins are allocated evenly between them. And pins in IPFS, you might, if you don't know, is like the way in IPFS in which we tell it not to garbage collect content. So once you've added something, you want to pin it to make sure it doesn't get garbage collected. And garbage collection can run like, it can be configured to run at like particular time intervals, or like when your repo is full, or you can actually run garbage collection from the command line or from the API. So making sure you've pinned stuff ensures that things don't get collected. So anyway, cluster allocates pins to particular nodes, and you can have them replicated to as many nodes as you choose. So you might have 6 nodes in your cluster, and you can have a replication factor of 3, for instance, and just pin it to make sure that the content is pinned to at least 3 of those nodes at any given time. If one goes down, then it will allocate them to another one. Cool. IPFS cluster. So alternatively, there's hosted providers that you can use. So if you're at a hackathon, or you want to get something up and running really quickly, or maybe you don't have the infra expertise, or you just don't want to manage that side of things because you're not interested in it, then like a hosted provider is a really great choice for that. what's cool about these is there's a few of them that actually store your data on Filecoin as well as IPFS, and that's really good because Filecoin storage providers are kind of like IPFS nodes. They're built on the same stack, and you can kind of think of them as just other IPFS nodes that are really strongly incentivized to store data. So what these providers will do is they'll make deals with these with the storage providers on the Filecoin network, and they will be obliged to honor that deal for the duration of the deals, which can be up to like I think 18 months right now. So so storage providers on the Filecoin network are like heavily incentivized to keep storing that data. Like they get paid to store it, but they also get paid to retrieve it. And if they happen to lose the data before the deal has ended, they get penalties for it. So like if these IPFS as a service providers happen to go away, then like if they just exploded and all of their IPFS nodes also exploded, then these Filecoin storage providers would still be storing your data for as long as necessary. So cool. There's loads of them. Infura, Pinata, Textile, Fleek, just a few. The new one is web3.storage. We'll look at storing some data on it. It's a brand new service that PL have launched, and it provides a kind of generous free data allowance, really simple API, and a great JS client library. Cool. So the alternative to like using IPFS as a service is to embed it, like I said. So so you can actually bundle an IPFS node with your app. So instead of talking over like a remote API, you talk to it directly, programmatically. And so for example, like if you're using the JS HTTP client, and you want to switch to using, like, if you want to bundle JS IPFS, the interface there is actually the same. So there's not a lot to do. If you're calling like IPFS, the client.add function to add some content to a remote IPFS, then if you're going to embed your JS IPFS into your application, then the function and interface is exactly the same. So you just call .add and it will store it on your embedded IPFS node instead. So so it's a really easy kind of switch out essentially, if you want to do that. Anyway, so embedding like an IPFS node in your application is awesome because your app is truly decentralized then. Like it's just another node on the IPFS peer-to-peer network, and data, when you add it to your node, is just added to your local device, and that's made available to the peer-to-peer network. And any data that you fetch from the peer-to-peer network comes it goes into your IPFS repo. It's cached there, and it's made available again to the peer-to-peer network. This is how peer-to-peer works: is that you get the stuff and you make it available regardless of what it is. So to kind of recap there, anything you add or fetch is available for others to fetch from you. So in embedded Go IPFS, we have a couple of examples here. We've got IPFS desktop that bundles a Go IPFS node with it. OpenBazaar is a kind of marketplace with a bundled IPFS in their application. I think that their app is called Haven. And Textile Photos, I think this is a bit old now actually, because I don't think Textile Photos is running anymore, but they had bundled an IPFS node in there as well. Again, the other alternative is embedded JS IPFS, and it's a full implementation of IPFS in JavaScript, which is amazing. So what's the differences here? Like in transports? Well, firstly, what are transports? Well, they are just the different ways IPFS can talk to other nodes on the network. There's no like IPFS transport really. It just uses existing transports or ways of communicating with each other. And so, we've got TCP, WebSockets, WebRTC. We've got the brand new one, which is Quick, which is all kind of supported. But these are the kind of tables. And the interesting thing here is that is that JS IPFS nodes, they have to run in different environments like browser and node. There's also Electron, but they have different capabilities in these environments. It depends what they offer. And in the browser, you can't just open arbitrary like TCP sockets. You can't listen on ports or IP addresses for connections. So you just don't get that ability in the browser. In Node, you do. And in Go, obviously, you do too. WebSockets is available in the browser. You can make outgoing connections. Like I said, it has to be to a SSL secured endpoint, have cores set up, et cetera, et cetera. In Node, you can listen on WebSockets. So you can accept incoming WebSocket connections and make outgoing connections. But yeah. WebRTC, I think WebRTC in Go is either just finished or still work in progress. I'm not quite sure. Quick is the new one that's been released in Go. This is super rad. I think it's UDP based transport, which is cool. And maybe that will arrive in JS IPFS at some point in the future. All right, that's transports. Just give you a little bit of an idea. So APIs. Okay, so let's talk a little bit about the interfaces that are available to interact with an IPFS node. So one of the first things that you'll encounter when you install IPFS is the command line interface. So you can just head on over to like ipfs.io, docs.ipfs.io, and then click down to command line reference, and you can see all of the commands. There's tons of them listed here. There's only a few that you probably will be using day to day, but they're all listed here. Check them out in the docs. Hang on, here we go. So you, once you've installed IPFS, if you type IPFS --help in the terminal, this is the kind of output you get. Lots of information about using this command line tool. I've highlighted adding and catting. So adding allows you to like import files into IPFS, and when you use IPFS add from the command line, all you're doing is importing a file into your local IPFS node. You're not sending it anywhere. You're just putting it into your local IPFS node. And what IPFS does is it talks to the DHT, and it says, it advertises that it is a provider for a particular CID. So it says, I have this CID and my address is here. If you need the content, then connect to me. This is my address. And what happens is that people query the DHT, find providers for a particular CID, and then they'll connect to peers that might have it, and then the data gets transferred, and we call that bit swapping because that's a fun name for it. Cat in this instance is not animals in any way. It's short for concatenate. If you know some Unix FS commands, then this will be familiar to you. And what all this does is it takes a CID or a CID plus a path. It's calling it a ref here because it can be a CID or a CID plus a path. And that will essentially go and get the data and print it out to your terminal. And so the cool thing about this is that you can cat any CID. Like you don't have to have it in your local IPFS node. Like if you have it, then that's great. It'll just be like outputted straight away. But if you don't have it, then what IPFS will do is it will search the network for that data. And if it finds it, if someone is available on the network who is sending out provider records to the DHT and are like generally connectable, then you should be able to connect to them and receive that data using CAT. So that is the true magic of IPFS, is that that whole like network or not is sort of abstracted and hidden from you. So you, yeah. Cool. So that's the output you get from help, fun times. And so IPFS HTTP API, when IPFS node is running as a daemon, it exposes a HTTP API, and this allows you to control the node and run the same commands that you would from the command line. Sometimes this is kind of preferable to embedding IPFS directly in your program. What's cool about this is that you can have one IPFS node running on your laptop and have lots of applications talking to it, essentially. It's good to do that because a long-running IPFS node will establish connections with peers. If you start your application and it bundles IPFS and IPFS just has to start up, then it has to bootstrap itself. It has to kind of get to know the network, establish peers, and also like any content that you get is kind of not shared with any other applications. If you've got lots of applications using the same node, then you can share the data that is in that node, and also the peers that it's connected to, and those good relationships it has. It's also kind of a resource thing. If you have lots of IPFS nodes, establishing, like, every application you have creates an IPFS node that establishes lots of connections with lots of peers, then you're going to see your CPU and memory drain a little bit faster than usual. So sometimes it is preferable to use the HTTP API over bundling it and talking to it directly. So yeah, that's the HTTP API. Again, just head on over to here. There's almost a one-to-one relationship between the HTTP API commands here and also the command line things. Like you got IPFS pin ls will map to a API v0 pin/pin/ls essentially. So it's pretty easy to map between the two. Oh, and by the way, the HTTP API is actually what the CLI uses. The CLI tool uses it to talk to a daemon, an IPFS daemon that's running. Cool. So to start the IPFS HTTP API, you'll need to have a running daemon, like I said, and this is what the output looks like from that. And a daemon, if you don't know, is just like it's a kind of like a background process that runs on your computer, and it will just stay running forever until you kill it for whatever reason. But it will essentially do all the bookkeeping stuff that IPFS needs to do providing to the DHT, but also accept incoming connections from peers, make them to outgoing peers when it needs to, and accept HTTP API connections and stuff like that. So what happens when you start an IPFS daemon is it starts up two servers, which we've highlighted here. It starts up the API and the gateway. And the API is for programmatically interacting with your node. So out of the box, it's kind of admin party. You get the whole of the API available to you. It's locked down to 127.0.0.1, so your own computer, so no one else can access it by default. You can configure this, but typically, like if you're going to run an IPFS daemon yourself in the cloud, then you'll want to restrict the routes that are available to whoever you're going to whoever's going to use it, and add some kind of authentication. We typically see people putting like an Nginx proxy in front of it, and then they'll add like basic auth and only allow certain paths to certain API methods. And that's kind of, I think, is similar to the Infura setup. If you've ever used Infura, they are like a service provider for IPFS, and it's basically the IPFS API or a subset of the IPFS API with some auth in front of it. So the gateway, this is a read-only HTTP server for accessing files from the IPFS network from your browser. So your local node runs them, but there's lots of publicly available gateways on the internet. And so this is what gateways are kind of like. They're like centralized points of access to the IPFS network. And so you essentially from your browser make a HTTP request to the gateway, and it will fetch content from any node on the IPFS network. So you can see here that it gives you access to this whole network of IPFS nodes that are running, but it is through a centralized point, which is the old Web 2.0 style, and we're not super cool with that. Just at the moment, we want to be in a distributed web style. So yeah, anyway, there's lots of gateways, but they essentially allow interop between the new world and the old HTTP world. So yeah, there's actually a gateway checker. So you can go to here, and you can see they just check that it shows you which ones are available and which ones are online. 22, 23, there's lots online stuff. The two main ones that you'll encounter quite often are the one that we run at ipfs.io, but also dweb.link. yeah, they are the two big ones. Gateway.ipfs.io, same, it's just an alias of that one, I think. Cloudflare also run one, which is kind of fun. Pinata, they're big, and Fleek, obviously. All of these people are big providers of IPFS storage. So, all right, back to the slides. Okay. Anyway, yes. So IPFS daemon, this is the output. These two addresses that we have here are what we call multi-adders. They kind of look a little bit like URLs, but they're better. They're self-describing, they're future-proof addresses. And like I said, you can actually configure the IP addresses and ports that these listen on just in case they're conflicting, or obviously if you want to actually expose them, you need to listen on something that's not localhost. Yeah, so okay, so for now, I guess the only thing you need to remember is the API server runs on localhost on port 5001, and the gateway runs on localhost on port 8080. So if you can remember those two numbers, you're all good. Cool. Okay, so time for our coding challenge. This is the first one of 4. I think there's 4, and so you can code along with this. It might be better to just watch. I don't know how. I've not tried this before with people, so we'll see. But maybe just watch. But here we go. So this is the coding challenge number 1, and what we're going to do is we're going to connect to a remote IPFS node over HTTP. So we're going to use the IPFS HTTP client to do that. And what we'll do is we'll just ask that node for its ID, and we'll just log it out to the console. All right. Let me stop my share. And then let me share everything. There we go. Right. Okay, so first of all, I need an IPFS daemon running. So you can see my screen, right? Shout if you can't. IPFS daemon, start her up. There we go. And you can see these two addresses that that we were just talking about. These are the defaults.
Sorry, Alan, there's just a few people asked what should they load up? Is it just the IPFS daemon for them?
Yeah, if you're going to code along, then start the IPFS daemon if you have it installed. If you don't have it installed, head over to ipfs.io.
I don't have the IP address. I'm looking for it. Sorry, John.
Sorry. Sorry, Alan, what was the address there?
So the address to download IPFS, just head over to ipfs.io. And I think there's probably a download link somewhere.
Okay. I'll find that and put it in chat for people. There we go.
So install, and then what you'll want to do is you can install IPFS desktop. That's kind of cool. You can also command line is what I'm using at the moment. But IPFS desktop that will also do. It will allow you to start up a node but through a nice GUI. I think it works on Windows and everything, so it's all good.
Awesome.
Cool. So once you've got a daemon running, then all I'm going to do here is I'm going to do the first couple of examples, just going to use HTML, regular HTML files. And like I said, what we're going to do here is we're going to get hold of the HTTP client, and then we're going to talk to our IPFS node, which is now running locally over HTTP. And we're going to ask it for its ID and print out that to the console. So here we go. Let's add a doc type, and then we need some script. And what I'm going to do here is kind of cheat. Go to, if you head over to npm npmjs.com/package/IPFS HTTP client. You scroll down to the table of contents, and in a web browser is what you want. and then just grab the script tag from here. We're just going to include this. You can install this package and bundle it up. Like typically, if you have a web app, you'll probably install it using npm, bundle it up with Webpack, and then serve it with your application. We're just going to use this this script tag today. So actually, I don't need that. So put that in, and have another script tag where this is where we're going to do the actual programming. So what we need is an async function. Whoops. We're going to call it main. Here we go. Let's call this function so it actually gets executed. Main. Here we go. Cool. So what this script will do here is this will add a IPFS HTTP client to the window object. So I can now do, I can create a new instance of one. And what I want to put in here is the multi-adder of the API. So if I head back over to here, I can just copy this API server address, put it in here, and we're good. I think we might need to wait for this. I'm not sure. Anyway, and then what we're going to do now is we're going to call ID. And this returns a promise as well. So we're just going to ask the HTTP. We're just going to ask the IPFS node for its ID. This has some identifying information about the node that's running. Cool. And so what I've got here, I think you can just run this in the browser, but I've got a static server. You can just npm install static server to get this, but it just allows you to view stuff in the browser. So this serving files here, so I'm just going to head over to the one directory. I'm expecting to not see anything here. This is good that it's a widescreen. But in the console, this is what I was expecting to see. It's logged out. So what's happened is it's communicated over HTTP with our IPFS node, and we have some information about this node. So we've got go IPFS 0.9 RC2 is what I'm running. This is my peer ID. This is like a unique identifier for my peer on the network. I've got protocol version, and these are all of the protocols that it currently listens on. So anyone talking these protocols can talk to us. So that's pretty cool. We got ping, we got CAD DHT, like the ID protocol, and bitswap, which is super important. So yeah, that's it. It worked. We communicated over HTTP with our IPFS node, and what's kind of cool is that I do believe. I can just call IPFS ID here, and we get the same information that we would have got in the browser. That's that. So it ends with 7CKJ. Let's just double check that was right. 7CKJ. Yeah, probably the rest of them will say the same. All right. Let's go back to the slides. Where did the slides go? Oh, here is this one. Cool. All right, that was a pretty easy coding challenge. It will get harder, I promise. All right, working with data. How are we doing on time? Okay, we're good. All right. Okay, so you should try and use the best API for the data that you're trying to store. Like IPFS is really good for files. It has some excellent APIs for abstracting what it does behind the scenes away, so you can just work with the data in the files. So IPFS add just allows you to add files to the IPFS node, and IPFS cat allows you to retrieve their content back. But what's happening behind the scenes is that when you add stuff, it actually takes that file content, that big long chunk of bytes, and it will chunk them up into smaller chunks. Each chunk has a fixed size, but then it will arrange those chunks into a tree. We call this a DAG, which is a directed acyclic graph. Acyclic means there's no cycles. but then this content, each content is becomes a node in this graph, and each node has a parent, and they eventually go up to a single root. And each node in the graph has a CID, a content identifier. This is what we use to identify content in IPFS, as per the name. But when you see the CID of some content, what you're actually seeing is the CID of a root node of a graph. You're not seeing, it's not the CID of the whole thing, it's just the root node. So that's kind of interesting thing to know about. So if you've got regular files, IPFS add and cat, they are for you. If you've got more complicated data structures, and you want to store some like JSON data perhaps that links to other JSON data, or you want to like construct that graph yourself in some way, then there is a API called the DAG API, which allows you to effectively craft these graphs yourself using IPLD data. IPLD is interplanetary linked data, and it's all about linking data and nodes together using CIDs and multi-formats like the multi-adder that you saw earlier. But yeah, you should check out IPLD if you're interested in doing more complicated like data structure creations. All right, so we're going to focus on like files for this particular workshop, because this is there's not loads of time. So let's try doing some adding in IPFS. So we're going to use IPFS add to add files. So how would you do that? Well, in the command line, I will show you in just a sec, but you type IPFS add, and then the file name, and that can be multiple files. You can also give it like a -r for recursive, and then a directory. So it will add all of the files in a directory, and all of those the files and directories off that directory, etc., etc. So you can add, as much data as you want in one command, which is rad. So IPFS add and file, and then if you're going to do that over the HTTP API, like I said, this echoes the command line, so there's just an add API v0 add, and that allows you to send files to the HTTP API, and you get back the CID, its size, and name. Ooh. Okay. Great. Coding challenge number 2. Let's use the HTTP client to add a file to IPFS. We'll add it to our locally running IPFS node. Share everything. Right. Close that up. That's fine. Okay, so we're going to start, I think, with what we had before, and head on over to challenge number 2. All right, let's add a file. Okay. Just one sec. There we go. Yes. Sorry. One sec. All right, so what we can call is IPFS add. And then we need that's not helpful. We need to add a file. We need a file. So what we're going to do is it's just going to add like a file input. And that allows us to select a file from our computer. File. Just going to grab hold of that DOM element, input equals query selector. I think I've not spelled document right. Cool. So I'm going to query. So this is like my CSS selector. There's no other inputs in this document, so I can literally use just input to grab hold of the only input element in this particular file. That's rad. And then what I can do is add an event listener. So input.add event listener. And when this input changes, I'm going to get it to call this async function. I'm going to move this stuff into the async function. So when we've got a file, this is when we'll add the file to IPFS. That makes sense, right? So we can use input.files, just a list of files. So input.files has like the files that are currently available or selected in this input element. And I can just add that file. And then the result, I have to await on this because it's a promise. And then I'll just log out the result. I think that's all I need to do. Cool, let's try it out. So now I'm in example 2, right? Okay, so I'm not expecting anything in the console because nothing has happened yet, but I am expecting a file selector to appear in my browser. That's cool. This is my GIF folder. This is where I keep all of my favorite GIFs. There's lots of cool GIFs in here that I like. I'm going to just upload. What should we do? Like this is the no time to explain. Get on the pony is one of my favorites. Cool. There we go. All right, so that changed. When I selected that file, it changed, and then it has logged out the CID and the size of that. So the CID is actually, this is actually a CID object. I should have called toString on this really. But anyway, this is the CID and the size of this this file, which is rad. We've added files to IPFS. Hooray! Oof. And back to oh yeah, I think that's here we go. Right. Back to the slides. Hooray. Okay, great. Oh, yeah, I should have showed you this before. This is basically what we did. Adding a file, we got a CID, we called IPFS.add a file, we got the result, and the file and the CID and the size of the file. If you need to look at the docs for JS HTTP client, then they are at that link there. I'll obviously share the slides after the talk. So that's cool. All right, onwards. So, all right, we added a file to IPFS over HTTP. So let's take a look what it's like to do the same thing, but instead of adding it to like a remote node that like maybe we're running, we've got like something that we're self-hosting in some way. Let's send the file to an IPFS storage provider like Pinata, like Textile, like Fleek, but we're going to use web3.storage for this, and we'll do this example from Node.js instead. But you can also bundle web3.storage for the browser as well. Okay, so this is pretty similar. Instead of IPFS client here, we've just got a web3.storage client, and in web3.storage you put a file and you have to give it an array because it accepts multiple files, and it always puts things in a directory, and then it returns you a CID, and you can just log out this CID. This CID looks a little bit different because web3.storage uses v1 CIDs, and IPFS currently uses v0 CIDs and is trying to move to v1 CIDs. By default, it will get there eventually, I believe. But web3.storage is brand new, so it's moved already to these new version of CIDs, which have some better performance elements, and also they are the best thing about these CIDs is that you can use them in as part of origins in URLs. If you have a case-sensitive CID like the QM ones you saw before, you can't have that as like an origin, like you know, CID dot your domain.com, because it's case the domain origins are case insensitive, so you lose like that information essentially when you use a case sensitive encoding, and so CID v1s are encoded using base 32 by default, which is all lowercase characters, so you can use them in domains. Anyway, that's not super important to your understanding. So let's just do the coding challenge. Right, share everything again. Here we go. Okay, that's what we'll do is we'll create another one. Okay, so we're starting from blank. We're on like a new JavaScript file. I've already installed using npm install web3.storage, and this gives me the web3.storage class. It also exports like some browser APIs that aren't available in Node yet, which is the file one. Web3.storage works with file objects. And then we're going to import FS, because what we're going to do is read this file that we have here called, this is another of my favorite, this is possibly my favorite GIF. It's a JPEG. And it's the hello, yes, this is dog GIF. So we're going to store this in web3.storage. Web3.storage is one of those services that stores things on IPFS in an IPFS cluster. So at least 3 of 6 nodes will have your data, but it also negotiates deals with Filecoin storage providers. So all of the data that goes into Web3.storage also gets backed up on Filecoin as well. So that's super cool. All right, what we're going to do, we need to create a client instance. So const client. And to create a new Web3 storage client, you do new Web3 storage. You'll need a token, which we'll get from our environment variables. And I'm going to get them from environment variables and not just paste the token into the file, just so I don't commit this to Git and share my token with everyone. So what I need to do now is go on over to web3.storage. Here we are, and once we're here, head on over to my account, and then I've created a token here for use in this demo. I can just copy that token, and then I'll use it in my env. So I can do export token equals. Here we go. I'll delete this token afterwards, so it's okay. Right, so that's ready for me to go. We've got a new client, and like we saw in the slides, to put data into web3.storage, we call client.put. And it takes a file, so it's an iterable of file-like, so it needs to look like a file. We need a file. Cool, so let's create a file, new file. But we're going to get the bytes from FS is going to read us some file data from /. Yes, this is dog. JPEG. And then file, you get to give the file a file name, so it doesn't have to be the same as the name of the file that you read from. And so we give it a name here. I'm just going to call it, yes, this is dog.jpg. So now we've got a file. We can put the file into web3.storage, and that gives us back a CID. Log it out, save it. All right, there's no browser involved here, but what we will do is, wait, let's just move into the example3 directory, node index. So this will hopefully upload it to web3.storage and give us back a CID for the file. Hooray, it's done, it's ready. And now you can IPFS cat that or retrieve it from a gateway or whatever you want to do with that CID. It is available for you in some node on the internet, which is super cool. And what's cool is you can give that CID to your local IPFS node, and it will ask the IPFS network who has that CID, and someone will be like, it will find a record that says that, that these few nodes have that content. It will connect to those nodes and then transfer the data to you so we can get hold of it. Very cool. All right, back to the slides. All right, talking of fetching files, let's do some reading. Reading, because we've put stuff into IPFS, but we haven't yet got stuff back out. So let's do that. Okay, so IPFS cat, like I said, it's not actual felines, it's concatenating in the command line. So you call IPFS cat and then the CID you want to get, and that will print it to the terminal, but you can redirect that output to a particular file by just using that arrow and naming the file you want it to appear in. So curl example using the API, very similar to what we've seen before. Yes, and so like I've already said it before, but this content is not necessarily in our local IPFS repo. It could be coming from the IPFS network, and it could be coming from a random node that we've never seen or connected to before, or like had no knowledge of previously. But it's peer-to-peer network that it's coming from, which is super rad. Yeah, cool. So I should demo this. Let's do a quick demo. Stop that. Share everything. Okay, so I'm going to take this CID and then I'm going to use, here we go, errors, that's great. IPFS cat. And then what I think I said, but web3.storage always puts stuff in directories. So if I'm going to cat this, if I cat this CID, I'm going to cat a directory, which I don't want, but I do want the file which is inside the directory. So what I can do is call, yes, this is dog, and then I'll put it to like dog.jpg. But wait, I'm gonna actually run this command in, I'm gonna run it here. And so I run it in the root of here. So we'll see it appear just here, when we run it, hopefully. Oh, yeah, there we go. There we go. Okay, cool. And there's a dog. We got it from IPFS and it got put there. Super cool. We can cat stuff out of the IPFS network. All right. So let's go again, back to the slides. Okay, so back to this IPFS daemon output and the gateway. Let's talk about the gateway. So the gateway, so this is a way of accessing data on a Filecoin network. So we're running one here at 8080. So actually what I can do is I can also cat that file from from my gateway. So I can I should just be able to hang on. Where's that CID? Let me just grab that. Here we go. And then I should just be able to go to 127.0.0.1 and then 8080. Here we go. And I get so page not found. Oh, yes. OK, I need /IPFS/ there we go. OK, so this is coming from, this is the gateway that my local node is exposing. And what's happened here is I've asked it for this CID. The local node's gone, well, I've already got this file, so it's in my repo, so it's able to serve it straight away to me. And so, like I said, everything is in a directory. On the gateway, you get nice directory listings like this. And there's one file in here, which is my dog. But what's kind of cool is that I can use any gateway. So you remember that gateway list I had before? I can use, there's a gateway called dweb.link, and that's a subdomain gateway. So I put my CID in the domain, in the subdomain, ipfs.dweb.link. And I should just be able to load that if it works. I think that's right. The beautiful thing about the gateways is that you don't have to rely on just one. You can go to any. Here we go. Oh, okay. So it's loaded. It's loaded here. It's loading on that one. Anyway, because of the way that the gateways work, the content that they fetch is like from the IPFS network, and like it has to find the content. So and it doesn't keep content around forever because there's lots of people hitting them. The public gateways that are available by IPFS are often in high demand. So your mileage may vary, but you can run, like I said, you can run your own gateway. You can also, like, I know Pinata actually allow you to just deploy your own gateway. So if you need like an application specific gateway, then you can just deploy one really easy with Pinata. So that's super cool. Anyway, so you can get this from the gateway as well. And what happens on these public gateways is that they go and find the content on the network, just like your node did, and then just display it to you. So essentially you can add content to your local node, or any content that gets added to any node on anywhere in the network can be retrieved through a gateway from any gateway, because it doesn't matter, because they're all accessing the same IPFS network. Rad. All right. Okay, how are we doing? Okay, we're running out of time. This is the last challenge. What we're going to do is just read some content, some data from web3.storage. This should be super easy. But what you do in web3.storage is you call get. You get the content with the CID, and then you get back a response object. And so this is kind of like if you use the fetch API in the browser, it's a response object that you get back, but it's a special response object that has a files property on it, and you can call .files, and what that will do is it will collect all of the files from that CID and give you back an array that you can just iterate over. All right, let's do that. Yeah, share everything. Here we go. All right, dog, away. Let's close up these things. Don't need these. Number 4, okay. I'm gonna start with what we had here. Paste that in, make some space. And so we're not gonna put files, we're not gonna do that. We're going to call client. Oh, whoa. Okay, client.get, and we know the CID. The CID is this CID here. We're going to grab that CID, put it here, and then we get, like I said, we get a response object, which is a it's a Web3 response, is what we called it. Yes, and so it's just a regular response. So you can do like res.ok to see if it worked or not. Obviously, if web3.storage doesn't have that CID, someone didn't upload it, then it will return like 404. So res.ok will be false. But anyway, we know this exists, so we don't need to worry about that. But we can call res.files to grab hold of the files that are available under that CID. So this is everything essentially. If you've got like a directory with subdirectories and stuff, then you'll calling .files will get you, like, it will have an array of files, and each file will have like its name, will have like the full path to that file, etc. And then what we can do is for loop over the files, and what we're just going to do file of files is log out some information about them, console.log. And what were we trying to log out? Yeah. Oh, hang on. That's not file.cid, name and size. Okay, that makes sense. File.cid. Whoops. File.name. And obviously, like, it's a file. It's like it's a web file, so you can call like a array buffer or stream to get the actual content of the file from the file. Like, it's just a so like for example, if you go and search like for a file, it's just a web file. This is what it is, and this inherits from blob. So you get the stream, array buffer, like text, methods, size, and type functions to interpret. But the file that we get back here is a special file. Like, the only difference between regular files and the file that we get back here is it has a CID property, which has the CID of the file. So here we go. Don't need FS anymore. I also don't need to import that. So let's just clean that up. Okay, I think this should just work. So let's clear that out. And then 4 node index. And so hopefully this should fetch the file Is it working? Oh, don't fail me now. It's like the last demo. Ah. Come on. Okay, I'm going to leave that running. And so what happens is if the request that it makes fails for whatever reason, then it will retry it. So it will try really hard to do that. Anyway, if that comes through, then I will show you. Right, back to the slides, but I don't think there's anything left as far as I know. Back to, yes, oh yeah, that's it. We're done. Thank you for listening. And I haven't gone too far over. Yeah, if you have any questions, then let's go.
Alan, thank you very much. That was thorough and very interesting. Much appreciated. George, did we take all the questions during the event? I dropped off for a minute, so
no, I think there's quite a lot that weren't able to be answered after Ryan left. So I haven't got my
let me
video
find out. Ryan did like a 6-minute stint where he just busted out all the questions.
Yeah, pretty impressive.
Okay, I'm going to basically read through. Let me see. So, have we covered how do I set up and embed an IPFS node?
How do you set
Quite
up
a hard topic. And embed an IPFS node?
Set up and embed. Very similar. So we were using the IPFS HTTP client earlier, and we just called HTTP client.create. If you're using JS IPFS, then you can import the JS IPFS library. It's just IPFS on. Let me just show you. Just head it. So we used this one, the HTTP client, but there's a IPFS package if you want to use JS IPFS. And similar, like it offers the same command line, similar command line to the Go IPFS one as well. Like I said, it might be easier to just use like IPFS as a service for getting started. And also JS IPFS in the browser, caveats apply, like it's not very well connected to the IPFS network. So you're probably going to need some kind of rendezvous servers to allow your application nodes to talk to each other. So yeah, your mileage may vary, but yeah, that's essentially how you do it. And like I said, the API is the same. So you can go, if you go to JS IPFS here, the repo, and then go to core API docs. We used IPFS.add, but all of these methods that we have here, and all of them listed in each of the files here, are the same as. So if you're using the HTTP API, you can use exactly the same methods for JS IPFS.
Okay. Cool. Can you explain how pins work?
Yeah, kind of. So what happens is you ask. So when you add content to your node that you have, if you're importing it, it will be automatically pinned. And pinning, like I said, is this way of telling your IPFS node not to garbage collect the content. So when your repo is full or at established times, your IPFS node might do a garbage collection run and clear out any old data. And like any data that you fetch from the network that you didn't add yourself is eligible for garbage collection. So if you do like an IPFS cat and then a CID and get hold of that content from the network, you know you didn't have it, then that content will be eligible for garbage collection the next time it is run, unless you call IPFS pin and then that CID, and that will tell your IPFS node to pin that content. There's also a thing called the Remote Pinning Services API, which I believe Pinata implement. I think maybe Textile are thinking about implementing it, but that essentially allows you to have like a remote node as something that also pins content for you. So one of the issues with adding content to your node and you being the only one who has that content is that if you like lose internet connection, or if you're on your laptop and you close your laptop, or if you got like a spotty connection in a coffee shop and you're the only person with that content, then people aren't going to be able to get it from you. And the cool thing about these IPFS storage providers like Pinata, like Fleek, is that they run nodes that are publicly available and online 24/7, and they pin data so it doesn't get deleted at all. So that's one of the benefits of that, and they'll always be available. So there's no you don't need to worry about users going offline and their content not being accessible to other users.
Cool.
Hopefully that answers it.
No, very thorough, thank you. Are we limited to 2 pins per local IPFS node?
2 pin? No, like you can pin as many things as you like, up to like your hard disk, like I think up to your configured repo size, which is configurable anyway, and obviously that repo size can be as big as your hard disk. So you can pin as many things as you like, and you can tell IPFS to pin things that you don't have yet. So you don't have to do IPFS cat and then IPFS pin. You can just do IPFS pin, and it will pin that content and like silently download that all of the data from the network if it finds it to your local repo.
Cool. Someone said, I noticed there's an IPFS section in the Brave settings. What is that for?
Yeah. So Brave actually have an IPFS node that I believe they package with Brave, and you can enable it, and then you can use IPFS : / and then CID in Brave. And what will happen is that request will actually go to the IPFS node. So it will be like asking your local IPFS node to give you something, and the IPFS node will be able to get the content from the IPFS, the wider IPFS network. So instead of using your browser and going through these centralized gateways, you're using an IPFS node to talk to a peer-to-peer network and retrieve the content.
Sweet. Cool. Lots of very specific stuff. Is hosting an IPFS node cheaper than AWS S3?
Well, I mean, I guess it depends where you host it. I don't know how like the cost of Pinata stacks up to as a service. Like I don't know, because if you're hosting your own, then you have to make the decision about like which virtual machine you're going to get wherever, or like if it's like in Kubernetes or whatever, like who's providing that, whether it's like DigitalOcean or whoever. So it really depends on where you host it, and what the hosting providers like cost for data storage is, and how big a disks you can get. So I don't know off the top of my head. Like what I will say is that IPFS is much more than just like storing files, because it gives you this ability to fetch content that you don't already have, and gateways, and also store and retrieve and work with IPLD data, not just file data. So it's kind of not super comparable. So like my gut instinct is like, if you're just comparing like storing files with S3, then probably not. But like it really depends on where you host it. If you're using a hosting like an IPFS as a service provider, maybe. I don't know. I haven't compared them. I know that. So one of the cool things about Web3.storage is that it stores stuff on Filecoin, and depending on like the price of the deals in Filecoin, they are often like less expensive than S3 for storing data for like however long it is. And that's a quirk of the storage providers that are operating on the Filecoin network. They get rewards for having capacity to store data, but they also get bigger rewards, or more likely to get rewards for storing actual real life user data. So often they'll be like, yeah, I'll store your data for like free or next to nothing, because it's not what's going to actually make the money is not the deal. It's actually the rewards, the block rewards that they get for storing the data.
Very good. How can we be sure of the latest version of the data when you press an IPFS, IPNS, IPFS, not a direct CID?
How can we be sure?
So the latest version of the data, basically.
Yeah, and so with IPNS, it's like quorum. You have to. I think we need a certain amount of. You need to agree. You need to find a certain amount of nodes that agree that you have the latest version. So it's not like 100%, but you have a good certainty that the latest version is the latest version, because other nodes on the network have agreed that is the latest version, essentially. And so like updates will, just like DNS changes would propagate through the network, so that they're not necessarily instant.
Okay. Kareem asks, sometimes when you try to run IPFS with React I don't know what this word is, instantiate the node in browser, it doesn't run in production, especially with the discovery that you have to do the rendezvous server. Is the HTTP one better then, or is there a workaround? If that doesn't make any sense, forgive me.
I mean, that sounds a bit like a bug, especially with the discovery. Yeah, like I said, in the browser, really difficult to communicate with other peers. I believe we do run like rendezvous servers for nodes for browser nodes to communicate with each other. Essentially, they're meeting places. So you go and say, I'm available here. Come and talk to me. Because browsers can't talk directly to each other, but through a known point, a centralized point, they can do that. The rendezvous servers are not always like running great. A lot of people use them. We don't recommend that you trust them for production. We offer them as a tool for like developing with. So if you're thinking about using JS IPFS in the browser and are going to need to rely on rendezvous servers, then we recommend that you run a rendezvous server yourself for your application, rather than rely on the nodes that are being kind of hammered by however many application developers.
Okay, very good. I think that's everything. Alan, anyone else have any other questions? Good. Alan, thank you so much, and thank you for also running a little bit over on time. It's evening for you, so yeah, thank you very much for your time this evening, and such a great presentation. And we will, Alan, if you wouldn't mind sending the slides over, maybe on the Slack, we're going to get the video and Medium up tonight for people to review, and I'm sure lots of people want to do the coding tasks and review and do stuff at their own pace. In the meantime, again, Alan, thank you so much. And
can I just say before we go, the final demo finally worked. I can quickly show you.
Yeah, go for it.
I didn't touch it. This is just, it's logged it out now. It eventually worked. Don't know when that happened, but it's logged out the CID, the file name, and the size.
Very good.
Don't know why it didn't work.
Cool.
All right,
great.
Thank you.
Thank you very much, and everyone, thanks for being here. And we will see you all next week. George, what have we got next week? I haven't got it up in front of me.
It's the intro to NFTs.
Oh,
gotcha.
Gravy. That'll be a big one. Okay, well, thank you all for coming. We'll see you all next week. Slides and video guts. Alan, thank you once again, and everyone have a wonderful evening, afternoon, morning, wherever you are.